For section 2, we're going to be looking at something called Pascal's triangle. We're going to be multiplying polynomials, and Pascal's triangle helps us multiply binomials raised to a power. So we're going to take a look at some of the patterns in Pascal's triangle, and then we'll look at how to apply that to polynomials in a minute. So what you need to know is that the first row is row 0. Pascal's triangle starts counting at row 0. And in each row, the first term is the 0th term, which once you get to pre-calc, you might use that information. For our purposes, we need to know that the first row is row 0. So then our second row with 1, 1 is row 1. And hopefully that makes sense why we start counting at 0, because our next row has a 2, and we call it row 2. Our next row has a couple of 3s, we call it row 3, and so on. So to generate the next row in Pascal's triangle, you add the two terms above it in the previous row. So 1 plus 1 gives you 2, 1 plus 2 gives you 3, 3 plus 3 gives you 6, and so on. So let's take a look at generating the the 8th row, row 7 in Pascal's triangle. Every row starts and ends with 1. Hopefully you noticed that pattern. 1 plus 6 is 7. 6 plus 15 is 21. 15 plus 20 is 35. 20 plus 15 is 35. 15 plus 6 is 21. 6 plus 1 is 7. And we always end our row with 1. So first we're going to take a look, before we use Pascal's triangle, at how to just multiply polynomials. Now I know a lot of you are used to foiling, but once we get into multiplying polynomials, that's not real helpful anymore, which is why I tried to focus on distributive property. So let's take a look at our first step. If you have more than 2 sets of parentheses, just choose any 2 of them to multiply. Remember, you can multiply in any order. I like to go left to right, so I'm going to choose my first 2 sets of parentheses. And I'm going to go ahead and distribute. So x times 2x gives me 2x squared. Now I have a 3x minus 4x is negative x, and negative 2 times 3 is negative 6. So I also like to multiply and simplify at the same time. It just saves me a step. If you have a hard time keeping track of that, go ahead and do that in 2 steps. Write down every answer you get when you multiply, and then simplify by combining your like terms. All right, continue this process until all of the parentheses are gone. Now I've got 2 sets of parentheses left, so when I multiply here, I can drop my parentheses. Also, I cannot use FOIL because my first term is a trinomial, and FOIL only works when you have a binomial times a binomial. So I have to use distributive property in this case. So I'm going to do 2x squared times 3, and I don't have a lot of room to show my work with the loops. So hopefully you can follow me. 2x squared times negative x. And now I have to distribute my negative x to both terms. So negative x times 3 and negative x times negative x. Now I'm going to distribute my negative 6 times 3 and my negative 6 times x. And then finally I'm going to simplify, combining all of my like terms. And of course our answer must be in standard form. So I'm going to start with the term with the highest exponent, and there don't happen to be any like terms, so we've got negative 2x cubed, 6x squared plus x squared is 7x squared, negative 3x plus 6x gives me a positive 3x, and my constant has no like terms, minus 18. We'll get one more. Here's another type, and I'm going to show you another process for multiplying. So option 2, if you don't like using distributive property, you can use what's called the box method. What you do is you set up rows and columns for each term. So my first term has, my first set of parentheses has 2 terms, so I'm going to have 2 rows. And put the first term on the first row and the second term on the second row, keeping that subtraction as a negative sign. My second set of parentheses has 3 terms, so I need 3 columns. First term goes for the first column, second term goes for the second column, third term goes for the third column. What we do once we have it set up is we essentially find the area of each box by multiplying the sides together. So my first box here has side lengths of 2x squared and 3x. So I multiply them together to get the area, which gives me 6x cubed. And I'm going to continue that process for the first row. 3x times 3x is 9x squared, and 3x times negative 1. Second row, negative 2 times 2x squared, negative 2 times 3x, and negative 2 times negative 1. Then I'm going to add my like terms and simplify as I add my like terms so that my answer is in standard form. Starting with my highest power is 6x cubed, no like terms. Negative 4x squared and 9x squared gives me a 5x squared. Negative 6x minus 3x gives me negative 9x plus 2.